Hey guys, Buildzoid here from Actually Hardcore Overclocking, and today we're going to be taking a look at the Gigabyte X570 Master motherboard. So this is obviously a AM4 motherboard based on the X570 chipset, meant for the new Ryzen 3000 series CPUs, and I am recording this video so far in advance of the actual CPU launch that I know basically nothing about the CPUs other than there's going to be a 16 core. And a 12 core and an 8 core. So I know how many cores there's going to be. I don't know when they're launching, how much they're going to cost, how they're going to clock, how much power they're going to pull. Basically, I don't really have any information that would really help me with gauging how overkill this motherboard in front of us is. Though it should be pretty damn overkill.
Before that, this video is brought to you by Drop and their HD 6XX headphones. The 6XX headphones offer high quality audio output with wide device compatibility. Masterdrop's 6XX also includes a 6-foot cable with 3.5mm plug alongside a 1/4-inch adapter for those who might want to plug into an amp. The 6XX focuses its energy into balancing the sound, leaning toward warmer and bassier audio. They're also easy to disassemble and replace individual parts, making these headphones trivial to maintain for long-term use. Learn more at the link below.
This is not Gigabyte's highest end board. There's also the X570 Extreme, but this has a lot of this keeps a lot of what makes the Extreme so very extreme. So then let's get right into it, starting off with the most interesting section of Gigabyte's new X570 series motherboards, at least in my opinion. I think a lot of people might be like, Buildzoid, the VRM really isn't that interesting, but damn it, this is my video, so I say VRM's most interesting section. So first of all, we have a V-Core. This right here is our V-Core VRM. Next to that, we of course have the SoC VRM. So that powers the system on a chip portion of a normal Ryzen CPU. I would assume that for the upcoming Ryzen 3000 series, this is going to be powering the I/O die. Also, if you're running an APU, this does power the iGPU. Though this motherboard, as far as I can tell, does not have any display outputs, so, you know, the fact that this can power the iGPU is kind of irrelevant in this case. Now, what makes this V-Core this VRM configuration really, really special? Like, right now, you might be looking at this and be like, oh, there's not that much. This is not that different from motherboards we've seen before. But this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 phases, and no doublers in the V-Core section, and then the SoC is just another 2 phases. So this is not, you know, these aren't fake. This is actually 12. This is an actual 12 plus 2 phase VRM, and the reason for that is like the X570 Extreme, the Master uses this chip right here, which is an Infineon XD. Oh, this photo is so high res that you can actually read it right off of the chip, but that is an XDPE 132G5C. So part number worse than ever before. IR35201 kind of rolls off the tongue. After you've said it often enough. This never does. This is just too damn long. But this right here is a 16-phase controller from Infineon. Infineon is the company that actually owns International Rectifier, so, you know, you can kind of consider them interchangeable. Now, this thing exists primarily for powering like insane server setups, you know, like non-consumer design, silicon designs where you have chips that are absolutely massive and can pull easily as much as 1,000 amps. Like, that's actually the use case for this. That's like the design. That's the use case for this controller right here. Is just like Infineon's marketing is like, this is the first proper 1,000 amp voltage regulator we've made. And it's really meant for servers, but hey, that never that's never stopped consumer motherboard vendors from, you know, just shoving super high-end voltage regulator components onto motherboards that are never going to power anything with quite as many cores or as much power consumption as a server platform. But so still, like, this is not a new thing that we have like high-end server grade parts on a consumer board, but it is a new thing that we have an actual 16 phase. Like, this was previously not possible. There's never been a controller that went all the way up to 16 phases. There's been, like, one or two controller... Well, there's... More recently, there's the MP2888, which goes up to 10 phases. But in the past, there's also been some controllers, like, I think UPI Semiconductor had a 12 phase at one point in time, but that quickly became... Like, nobody really used it that much. But 16 phases, this is a first. Like, this is the first time there's ever been a controller that goes up to this many phases. So, props to Gigabyte for just going right for it as soon as it arrived. It's like, oh, yeah, we like having a lot of phases. We would prefer not having to use doublers for them. And the reason why you'd prefer not to use doublers to get lots and lots of phases is that while doublers have their upsides, you know, you can get better VRM efficiency, you can get reduced output ripple because you effectively have all your phases interleaved. The downside to having a bunch of doublers is that you put a bit of delay onto your PWM signals, and that can potentially that basically makes it more difficult to optimize the transient response of the VRM, which, you know, for CPUs not really a huge priority, because unlike GPUs, CPUs don't really power cycle anywhere near as hard. But still, you know, it can make the difference. Like, there's ways to design around it, but ultimately, hey, if you can buy a 16-phase controller, you can have all the benefits of having 12 interleaved phases, and none of the downsides of doing it with, you know, six phases and a set of doublers. So, yeah, awesome controller to see right here. And the X570 Extreme also uses it, and actually uses it to further capability of the 14+2 configuration. The +2, of course, here is for the SoC VRM. Now, the actual VRM itself, vCore and SoC VRM, the power stages used are International Rectifier 3556s, which actually puts this X570 Master well above, say, the Z390 Master in terms of VRM power delivery capability, which is just kind of a interesting thing in my opinion, because, well, not well above. Well, it's 25%. I'd consider that well above. So the 3556 is a 50 amp power stage, whereas what you'd find on like the Z390 Master is a 40 amp power stage. They both still have 12 phases. It's just that these phases are quite a bit more substantial than what you would find on the Master. So what that means for the vCore VRM efficiency here, keep in mind, I have no idea how much power a overclocked 16-core Ryzen 3000 series CPU is going to pull. Just absolutely no idea. I've not been given that. I've not been given any reliable information on that. But we can still talk about how, you know, the efficiency capability, like the VRM power delivery capabilities, and just kind of once the CPUs come out, we can go, okay, well, they pull this much, and then you can fit what this motherboard, this motherboard's efficiency, power delivery, efficiency and power delivery. Like, the thing is, if your VRM is not very efficient, that just means you need to put a bigger heatsink on it. Now, at some point, your heatsink's just never going to be big enough, so you need a very efficient VRM to be able to handle a lot of power without, like, resorting to water cooling the VRM in order to keep it from overheating. So anyway, VRM efficiency, we're going to be looking at 1.2 volts output, because that's the voltage that the data sheet of these is spec'd in. And it's just convenient for me to use, especially since I don't know if we're going to be running these 16, like, I don't know if we're going to be running the Ryzen 3000 series chips on 1.5 volts or 1.1 volts, right? Like, it's 7 nanometer. We could be looking at very little voltage. We could also be looking at a ton of voltage. Like, who knows? Who knows how AMD decided to go with the chip design. 400 kilohertz switching frequency, because again, that's where the data sheet is spec'd at. Also, Gigabyte tends to actually, like, Gigabyte's recent motherboards that use the various IR3550 series power stages, so like 3553s, 3556s, they all tend to default to 400 kilohertz switching frequency. So I'm assuming they're not going to be changing that for this one. So 400 kilohertz switching frequency and 5 volts drive. And the reason why I'm pointing out the 5 volts drive voltage is because the data sheet for these actually has all of its efficiency curves done at 7 volts drive, which is not great for the reliability of these power stages. Like, you can run them on 7 volts, they're just not going to last as long. So essentially they're overvolted for the purposes of the efficiency curves in the data sheet to make them look a bit better. There's some GPUs that actually, like, run these on like 6 volts, but Gigabyte, for their motherboards, they always go with 5 volts. So 5 volts drive for these. Ultimately, it doesn't really make that much of a difference to the overall efficiency. It's just a couple percent. Anyway, so 100 amps output at 1.2 volts, so about 120 amps, 120 watts going into the CPU. You're going to be looking at about 13 watts of heat dissipation. So, you know, like VRM shouldn't even need a heatsink at that point. Plenty of surface area, lots of phases. You know, you're looking at a little over a watt per power stage in the VRM. So you shouldn't even need a heatsink at that point, as long as you have even just moderate airflow over the VRM section. Now, going up to 150 amps, 1.2 volts output, you're going to be looking at about 17 watts of heat coming off of the power stages again. So at this point, you know, a heatsink might be advisable, but it doesn't need to be very substantial, especially considering that this is a 12-phase. Actually, you'd probably be able to get away with no heatsink, depending again on your airflow situation. And going up to 200 amps output, we're going to be looking at about 22 watts of heat coming off of the power stages. That basically, well, at this point, you do want to have a heatsink, okay? It doesn't need to be the world's biggest heatsink ever, but you do want to have a heatsink. Airflow is kind of optional still. And especially considering that, like, with the heatsink that Gigabyte has on the Z390 Aorus Master, if they go with, like, the same style of heatsink for this board, like, yeah, this will be no problem. Will be no problem for this board to handle. Now, going up to 200, not 250, at this point, like, 200 amps, I think, is kind of unlikely for a Ryzen 16. Like, even for the 16-core, I think this is, like, a worst-case scenario situation that you would hit 200 amps on ambient cooling, because the thing is like, it's one thing to say, oh yeah, you can totally shove that much power into the CPU. It's another thing when you need to actually cool that much power. And generally, well, I don't know how the thermal density is going to work out. The cores are going to be kind of offset from center, so that might affect how efficient various water blocks are. So yeah, not really sure how this is going to work out. I kind of think this might be the limit for a CPU in this package size. Then again, if we think back to the FX... Well, no, the FX series CPUs were right around sort of the 1.5 volts, 200 amps. Like, if you had an FX8 core, that's roughly what you'd be looking at. So, yeah. This is a huge upgrade over, like, the best AM3 Plus motherboard ever made. This VRM right here. Like, it doesn't even compare. So yeah, I'm just realizing how like the AM3 Plus motherboards were so sketchy to run. Like, some of them are so sketchy to run an 8-core on, and then it's like, oh, here it's like, you know, just 22 watts. Yeah, so who knows? Like, this might be pretty much the limit, if that's even possible. But going up past that, you know, just for the sake of what the motherboard can do. 300 amps output, you'd be looking at about 36 watts of heat. A good heatsink design, a good heatsink and some airflow should have no problem handling that. Going up even further than that, 400 amps. At this point, we're kind of going outside of where you'd optimally want to run this VRM. Like, this one's really designed for sort of the 200 amps. That's kind of the sweet spot for this VRM, is 150 to 200 amps. And going up past that, if we go to 400 amps output, you're going to be looking at about 59 watts of heat, which is like, that's a lot. You can definitely build, you know, VRM heatsinks that can handle that, especially considering that this is a 12-phase, so it's not all crammed into just a couple power stages. But it is still, like, that's not, you know, an ignorable amount of heat. Luckily, I think 400 amps is probably only achievable if you're on LN2 cooling. And even there, it might not be possible. Who knows? Like, again, I have no details on the CPUs, but if, you know, like, on LN2, the thing is, you're not going to be running that load for a very long time, so it doesn't actually matter that, you know, as long as the VRM doesn't overheat before you finish the benchmark, you're fine. So, that there is, like, that's concerning for, like, long-term usage, long-term loads, not necessarily for, you know, even extreme overclocking. And going up to 500 amps, at this point, we're very much, you know, 93 watts of heat output. The thing about, like, a lot of the power stages, when they're spec'd for 50 amps, what the way that spec works is considering a single power stage, which is like basically surrounded by a great big square of just empty copper. And it's like, yeah, we can totally push 50 amps through that one power stage under these testing conditions. It doesn't really consider what happens when you put, 12 of the 50 amp power stages next to each other, and it's like, well, now we have 93 watts of heat instead of just, because this is a little over like 8 watts per power stage. So if you have one of them, that's not really a big deal. If you have 12, well, actually it's slightly under 8 watts per power stage for this. So, if you have one of them, not really a big deal. If you have 12 of them, you got a problem. That's 93 watts. You actually, like, a lot of airflow, substantial heatsink. This is not something you just kind of, this is not something you would actually want to hold as a sustained output out of this VRM unless you have something like a Delta fan cooling it. Still, a very powerful VRM on this motherboard. I mean, it is stronger than what you get on the Z390 Aorus Master. It's like it doesn't it does get better than this, but I'd say better than this is kind of unnecessary. So. Yeah, the extreme is extreme. The extreme is extreme for a reason. It's even better than this right here, but this already is more than enough, especially within sort of the saner current draw levels, even up to 300 amps. I mean, that's still, if you have a good heatsink design, you can totally handle 36 watts spread across 12 phases. That's not a problem. So, yeah, Z3, this thing's just kind of carrying on the legacy of the Z390 Master, where it's like we've got a 12 phase, we've got good power stages, got a solid VRM, and they've actually upgraded the power stages on this thing. So, yeah, it just gets better. Then for the SoC VRM, we have more 50 amp power stages. Since this doesn't have a display output, and the APU iGPU doesn't really pull that much power. It's just like, well, this exists. Don't worry about it. The main concern here is the V-core. Also, Gigabyte is going with the dual 8-pin power connectors for CPU power. I've heard some things about the 16-core. I have serious doubts that you would ever actually exceed the power delivery capabilities of the single 8-pin. You can easily, I've been pushing 300 watts into ITX Z390 boards. Okay, actually, I think I've been pushing over 300 watts into Z390 ITX boards. You're nowhere near maxing out this 8-pin power connector until, the 8-pin can do at least 400 watts if you have a halfway decent power supply. And it will get warm, okay? It's not like it's going to be ice cold, but it will still be within the tolerances of all of the materials used to build it. So, yeah, I don't really think the 16-core has a chance of overloading the single 8-pin. But maybe if you're on liquid nitrogen, who knows? Maybe the 16-core scales to 2 volts at minus 196 degrees, pulls 1,000 watts. There's already a different 16-core from Intel that does that, so it could be possible that this ends up doing something similar. And in that case, the extra 8-pin would be kind of handy, wouldn't it? But yeah, for ambient, the single 8-pin is more than enough. So. Yeah, that's the power delivery on the board. For the CPU, moving on for the memory power, we just have it's nothing impressive, but it's nothing bad. So we've got the standard Gigabyte single phase. We've got our RT8120 voltage controller over here. We've got our 4C10N high side MOSFET, then another 4C10N as a low side, and another 4C10N as another low side. This is Gigabyte's go-to single-phase memory VRM for, the last several years. I want to say that they've just been running this memory VRM, and it works fine. It's perfectly acceptable. I've never had any, I've never had any sort of memory overclocking issues on Gigabyte motherboards related to the actual VRM. Most of the time when you're looking at DDR4 overclocking, because DDR4 really doesn't pull that much power, the main concern with DDR4 overclocking is everything that happens between the memory slots and the CPU, and arguably the output filtering of the VRM. But and that looks like a pretty standard Gigabyte affair. These capacitors right here, I'm wondering if that might be just because this isn't, technically this board is a engineering sample. The retail boards are always Rev 1.0. So this is an engineering sample board, so it might be just like that they're not there for testing or something. I'm not sure. Normally I would assume these end up being populated, because it's pretty standard to have bulk capacitance between the memory controller and the DIMM slots. That's just kind of a standard thing for a lot of higher end motherboards. But so you can mess around with like the output filtering, but most of it comes down to what do you do with all of the traces running in this area. And in that aspect, all of Gigabyte's X570 motherboards are actually going to be using a daisy chain memory layout, which favors a 2-DIMM, which generally favors 2-DIMM configurations because there's basically two layouts that you can have on a motherboard. There's T topology, where you have equal length to both DIMM slots on each channel. So like this is one channel, and then you have the next channel. So T topology looks something like that. Daisy chain just looks like BAM. It's much easier to lay out. It's much simpler to lay out, and daisy chain actually, like the daisy chain's issue is that you end up with a timing difference between this DIMM and that DIMM. There's a timing difference between the two. But if you're only using, you know, one DIMM slot on each channel, so like a 2x8 configuration or a 2x16 configuration, daisy chain works really, really well, assuming the motherboard's BIOS is also tuned for it. Because, you know, if you screw up your memory training setup, then it kind of doesn't matter what layout you have, because it's just like, well, the board's going to be set up wrong. But since with AMD CPUs, there's the AGESA, which is much like, as I understand it, the motherboard vendors don't have anywhere near as much power to mess with the memory training algorithms on AMD CPUs as they have on Intel. So I would assume, like, and the thing is, on X470, all of the, like, MSI uses daisy chain, Asus uses daisy chain, ASRock uses daisy chain. So I'm assuming basically what's been happening is that the ASRock, Asus, and MSI feedback to AMD about, hey, how to tune the memory training algorithm has been tune it for daisy chain, and at this point it's just like, well, it works best with daisy chain, so everybody's going to daisy chain. So I think ultimately the board should be, you know, if nothing else, pretty consistent, and I'm kind of happy that Gigabyte's going to daisy chain, because in the past they've used T topology, and the thing is, yeah, it really doesn't work. It does cap your maximum frequency when running 2 DIMM slots over running when running 2 DIMMs over 4 DIMMs. So this should work better for, you know, the more casual memory setups instead of the insane like 4x8s or 4x16 setups. You can still make daisy chain work in a, you know, 4x8 or a 4x16 setup. It's just a bit more work, but considering that daisy chain has been standard for X470 for basically 3 of the 4 big motherboard vendors, I'd assume that it's already AMD already has it pretty well fine-tuned even for 4 DIMM configurations. So anyway, that's our memory power over here. And then we've got a postcode, which is a nice feature to have if you're doing any, you know, for troubleshooting any kind of boot issues. Much more useful than just having some troubleshooting LEDs, though you do have those as well. So this is like a quick indicator of what's wrong. This is the look it up in the manual indicator, and you might actually get something that's more specific than just, oh, there's something wrong with the CPU. This can tell you things like, oh, you failed memory training, or you failed, your GPU's not, the motherboard can't see the GPU, you know, those kinds of errors. The postcode, much more helpful than just some LEDs like that. So that's a nice feature to have. Also have voltage read points up here. You know, for people like me who aren't happy with just having with just having with just software readouts, because they're not always that accurate. These are just solder bumps, so no nice header. But at the like, Gigabyte is ultimately gearing most of like their motherboards towards gamers, not extreme overclockers. So I totally get why there's not like connectors on that for multimeter probes. But yeah, it's, you know, at least it's there. Much simpler than having to, like, well, actually, for me, if I'm going to be soldering connectors to the motherboard, I might as well just solder them directly behind the CPU socket or something. So at that point, it kind of doesn't matter. But if you don't want to modify the motherboard, this is a lot more convenient than trying to stab the back of the board with a multimeter. That's generally quite hard to do, especially if you have it on a test bench. Actually, pretty much impossible if you have it on a test bench. We got a power button, we got a reset button in the correct location. They're also located on the back, but if you remember some of my past videos with Gigabyte boards, I've actually complained that, like, why would I want the power button on the rear I/O if I'm going to be using the board on a test bench? So yeah, now we have them in the right location. We've got we have dual BIOS, so a BIOS selector switch and a BIOS dual BIOS mode enable disable switch. I'm not sure which one's which, but basically, you know, Gigabyte's dual BIOS can be a little bit less than cooperative when you're doing your memory overclocking and just failing to boot over and over and over again. It can sometimes get a bit trigger happy and go from the main BIOS to the backup BIOS when you don't need it. So here you can force it to stay on one BIOS for your entire overclocking session, which in my opinion, that's really convenient. Because the thing is, if your BIOS, like if it goes from the main BIOS to the backup BIOS, the BIOS profiles are actually tied to the BIOS chip that you're using. So if you save a bunch of profiles on the main BIOS, and then it switches to the backup, you don't have any of your profiles, so you need to switch back over. And on a lot of motherboards, that's like up until like on motherboards where you don't have the switches, that's just not possible to do easily. So this is a really nice feature to have on Gigabyte motherboards. It's standard for all of their high-end stuff, so no surprise that the X570 Master has it, but still nice that it's there. We've got our 24 pins, some fan headers, debug LEDs going down. They've kind of ruined the color coding on the... Why is that freaking out? They've kind of ruined the color coding on the front I/O. Like, normally it would be really colorful, and now it's just grayscale, which is... like, I preferred it when it's colorful. I get that it might look nicer in somebody's PC, but it's just, like, it was easier to work with when it was fully color-coded, in my opinion. And pretty much covers all of the overclock. Well, no, we do have a socketed. So here's your BIOS chips. Your backup BIOS is soldered onto the board. The main BIOS is socketed. So if you somehow manage to brick both the backup and the main BIOS, you can potentially just ask Gigabyte to send you a new main BIOS chip, and you'll be back up and running. So yeah, this is also a nice convenience feature. And other features we have on the motherboard, there's going to be Wi-Fi 6 add-in card right here. This is a 2.5 gig LAN controller from Realtek. If you're like me and you think Realtek sucks, there's also a 1 gig Intel LAN down here. So you're covered. 2.5G. I haven't used a Realtek network controller in ages and ages and ages, so I don't know how bad it is. But back when I had a Realtek-based motherboard, it was not a good experience, so let's put it that way. But that is a 2.5G, and you still have your Intel LAN, so, you know, you have options. So that pretty much covers it for the... yeah, that covers it for this board. I mean, the only other thing worth mentioning is that the X570 chipset, as you can kind of see, is a lot of silicon. It gets kind of hot, and if you're doing... basically, from what I've been told, if you're running M.2 SSDs in like a RAID 0 setup, this thing needs active cooling because it just gets really, really hot when doing that. Otherwise, it's actually just fine, but RAID M.2 setups are a bit, like, they just get hot on that. So it's one of the issues that's actually been, like, that's been one of the main issues with the X570 platform, is just, like, getting that chipset's heat output under control, and eventually that didn't work. Like, they never managed to solve the issue of it running really hot, so now it's just, like, boards have fans on that. But the fan can take care of it, and, you know, ideally... like, I'm not sure about this, but I'd hope that the board has a hybrid fan mode, so the fan only kicks in when it's actually necessary instead of just all the time. Though even if it's spinning all the time, as long as it's not like a super high RPM, it should be relatively okay. So yeah, that's it for the X570 Master from Gigabyte, the Aorus X570 Aorus Master. There, finally got the name. I'm still like... It's always going to be Gigabyte for me. Always. It's not a significantly better name, but I do prefer... I'm used to it, at least. So, that's the X570 Master. It definitely looks like a really... Like, I think this looks like a really solid motherboard to me. Quite possibly, like, it does everything... Like, it kind of does everything. The Extreme, you know... It's kind of Extreme. The Extreme adds the 10 gig LAN, slightly big, well, actually not slightly better VRM. Like, it's on a whole new level of VRM, but it's just like, this is already so good that I don't really see, like, I wouldn't, you know, push you towards the Extreme just because it's like, oh, the VRM's like way better. It is, but it's just, you probably won't need it. So yeah, but this is definitely a really, really solid X570, you know, solid looking X570 motherboard. Kind of like looking at the Master and the Extreme, it kind of feels for me like Gigabyte basically what made a checklist of things I've complained about in the past when looking at their motherboards, and then they just went and made sure that there's nothing on the, like nothing has been left unaddressed. It's like Buildzoid's complained about this in the past. It will not be on our motherboards anymore because we got the dual BIOS, we got everything. Solid VRM. There's just nothing really here for me to complain about. So yeah, that's it for the video. Thank you for watching. If you'd like to support Gamers Nexus directly, there's store.gamersnexus. There's the Gamers Nexus Patreon. If you'd like to buy some Gamers Nexus merch, there's store.gamersnexus.net. And if you'd like to, you know, see more content with my beautiful voice doing it, I have a channel called Actually Hardcore Overclocking where I do a whole bunch of overclocking stuff. So yeah, that's it for the video. Thanks for watching, and goodbye.